Hello everyone. I wanted to make a quick video for you to help you with a word problem that we didn't get to in class. And this is in Module 2. So when we were working on um, composition functions, we had to skip this word problem to make it into inverse functions. So I wanted to give you a chance to kind of see this worked out in case this was something you were having trouble with in your homework. All right, so we have the surface area, S of r. So this is a function that gives us the surface area of a spherical balloon with radius r meters, and that surface area is measured in square meters. So S of r gives us surface area of a balloon with radius r, and that function looks like this, 4 pi r squared. Okay, great. And then the radius, p of t, so this is a separate function, p of t is a function that tells us the radius of the balloon in meters after t seconds. And that function looks like this, 8/3 t. And we need to write a formula for the surface area, n of t. So we need to make a function named n of t that gives us the surface area after t seconds. Okay, so my goal is to write an equation that gives me surface area when I plug in t seconds. But I have a function that gives me surface area already, right? Right? It's this one, S of r. That told me surface area too. But that wasn't, I didn't plug in t seconds to that, right? What did I plug into that one? My input there was an r, which was a radius. I don't want that. I want the input to be seconds. Okay, so let's think about this. I've got a function S of r, and I'm just going to say I get a y value out of that, right? And so when I plug a radius in, I get surface area out, right? That's S of r. That's the one that I have. And I know it's 4 pi r squared. We'll come back to that in a minute. Right now, I'm just trying to figure out what's going in and out of these functions so I can figure out how to get to what I need from what I have. Okay, so this isn't quite what I want because I want to plug in seconds, not a radius. But I also have another function here that we haven't really looked too much at, p of t. Again, when I plug in a t value, I get a y value out. I know I have a specific function in here. We'll deal with that in a second. Right now, I want to know what goes in and what comes out. So what's going into this p of t? All right, the radius p of t after t seconds. T seconds. I put a time in seconds into my function, right? I'm plugging time in, and what I get out is the radius. Okay. So I plug time into P and I get a radius out. And then I plug a radius into R and I get surface area out. When we look at this together, something that I want you to notice is that here I get a radius out and here I put a radius in. And so do you see that because these two things match, I could take the output of P, which is a radius, and plug it into S because my input of that one is a radius. So this is going to tell us kind of how to get to where we need to go. I could do S of a radius, right? We do S of a radius, and I know that P of T, my output there, is a radius. So I can actually do S of P of T. because this is a radius and my input is a radius. And notice overall here, switch colors here for a second. I like colors. Hopefully that doesn't distract you. Overall here, what my input is I'm putting a time in seconds into this function, right? I put a t in first, and then I'm going to plug that into p, and I'm going to get a radius out. And then I'm going to plug that radius into s, and I'm going to get a surface area out. And notice this is what we wanted. I wanted to put a time in and get a surface area out. If I compose s of p of t, then I'm going to get this function that I want, which they told me to do n of t. So now I just have to do the function composition to find what that n of t looks like. So now let's go ahead and do that. So my n of t is going to be s of p of t. And again, if I plug t into p, then what I get out is this guy, 8/3 t, right? Function notation. And now this notation tells me to take 8/3 t, and in my function s, anywhere I see r, I'm going to replace it with 8/3 t. I'm going to plug this into my function s, which is right here. So anywhere I see an r, so 4 pi r, I'm going to replace r with 8/3 t, and that r is squared. So that is what my function is going to look like. Now we just have to go ahead and evaluate this. So I'm going to have 4 times pi times 8/3 t times 8/3 t. So 8/3 times 8/3 is going to be 64/9. And then t times t is t squared. Right? 8/3 t times 8/3 t gives us 64/9 t squared. And I totally put that parenthesis in the wrong spot. Sorry about that. And now we can multiply everything together that multiplies. This is 4/1, so I'm going to multiply my fractions here. 4 times 64, go brain go, that should be 256. And then 1 times 9 is 9. I still have that pi, and then I have the t squared over here. This is my n of t. That's my formula for n of t, where I plug time and seconds in and I get surface area out. This is the equation that it's looking for. So for these word problems, what I want you to do is start with your given functions, figure out what's going into and what's coming out of each function, and you're looking for something that matches. That's going to tell you which function to plug into which function, and then you can do your function composition and find that formula. All right, I hope that helps. Have a lovely day, and I will see you next time.